Good morning, sir. With our
It's a very great privilege to stand before honorable people again today to make a presentation in line with our team building section. Today being Friday, the 28th of July 2023. So, in our team building section today, our topic will be foundation foundation concepts in the AEC. AEC is meant to be architecture, engineering, and construction. Okay, so and today we are looking at part one of this topic, foundation concepts in the AEC. Okay, now move to the next slide, please. So in the content, in summary, we are going to look at in this part one, we are going to look at the following. Number one, the meaning and the functions of foundation in construction. Number two, the different types of foundation. And then number three, types of shallow foundations and their advantages and disadvantages. So that is the package for this particular. Let's go to the next slide. In construction, a foundation refers to the lowermost part of a building or structure that is designed to support the weight of the entire structure and to transfer it to the underlying soil or rock. Now, there is foundation for everything. There is foundation for every endeavor in life. And in construction, there's also foundation. The purpose of every foundation is to bear the load of every other thing that will come upon it. In the family, the man is the foundation. So he will bear the load of the whole family and then transmit it to his maker, God. Okay, so but in construction, the foundation happens to be the platform that will carry all the load of the building, no matter how big the building is. So the foundation will carry the load and then gently transmit it to the underlying soil without causing any havoc, without allowing the load to overwhelm it, without allowing any other external factor to affect it. So that's what foundation in construction is all about. Next slide, please. What are the various functions of a foundation? The function of a foundation is summarized in three major points. Number one, it distributes the load evenly. Okay, so foundation evenly distribute every weight of the building and ease occupants to the ground. So it does not matter, for example, now there could be a point load in a given part of the building, section of the building, and then maybe another place distributed load. Dead load is there, life loads are there, many things. But you see, the foundation ensures that no matter the loading system inside the building per time, that the load are evenly distributed so that there is no issue. Because if the loads are not evenly distributed at any time, it will cause a havoc that will be seen. The building will start to slant one corner or one thing. But you see, in every building that has a strong foundation, there is no such thing. Everywhere is okay. Number two, what is the second function of the foundation? Stability. Foundation anchors the building to the ground, resisting forces such as wind force, earthquake, and other external forces. Wind force is a major force, especially when we are talking about skyscrapers, tall buildings. You discover that the wind force comes to play a great role, And then, no matter how the wind force is, every external force or earthquake or any type of land movement, settlement, the foundation is strong enough to be able to resist all these external forces and make sure the building keeps standing. So anything that happens to the foundation will happen to the entire building. When we hear about building collapse, most building collapse is until the foundation is affected. That's when the building will collapse. If the foundation is very strong, do you know that even if you remove these ones are just support, they are not even structural elements. But if the foundation is very strong, you remove some part of structural element. It's only that aspect that will get damaged, but the foundation will remain the same. Most of the major building collapse is due to foundation. The effect goes to the foundation. That's why you see collapse, pure collapse. Okay, so it maintains stability, fight against every external forces. Then number three, it controls settlement. It ensures that there is no settlement of the building. Settlements are as a result of land movements. There are some land movements that keep on going on the ground from time to time because of many other factors, seepage, underground infiltration of water, this, that, and that. So no matter the land movement, the foundation takes care of all those things. That's why before any building, the standard is that before any building is constructed, there should be soil investigation to test some of the characteristics of the underlying soil, to also check the environmental factors that will play, like the wind and other history of that area, to check where there have been a landslide, erosion, and all that. So there will now be environmental impact assessment of that. And then after that, we can now gather all the information together to have a very solid foundation. Please, next slide. Now we go to the types of foundation. Now, foundation are basically there are basically three different types of foundation as I classify it here, and under each of them are other types. Okay. Now the three are: number one, deep foundations; number two, shallow foundations; and then number three, floating foundations. These are the major three types of foundation that we have in the AEC. Okay. Now, the major differences between the please next slide. For shallow foundations, you discover that it is a type of foundation that is used to support and distribute the load of a building or structure to the underlying soil at a relatively low depth. So the depth is what distinguishes the deep foundation and the shallow. Just like the name applies, shallow, something that is not too deep. While on the other hand, the deep foundation, please, while on the other hand, the deep foundations are very deep. In fact, they are used to support structures that are bigger in magnitude and taller in height. So, because of the tall nature and the bigness nature and the heaviness of those structures, they need to go deeper. Now, normally, it is there is a certainty that works with this. So it says the taller the building should go, the deeper the foundation should go, so that it can be able to support it properly. Otherwise, if that ratio is not carried along properly, you discover that there will be a toppling at the end of the day, and then the building will collapse. So that is shallow foundation. And in today's lecture, we'll basically focus on the shallow foundation. But before I continue with the shallow foundation, let me quickly say something about the third type of foundation, which is called the floating foundations. Now, that is the floating foundation is not too much a common type of foundation, you know, but it is very very important. Now, those are the type of foundation we see probably in the sea shores, where we use to prepare some landing for ships, anchorage for ships, many other things that we do around the seashore area. Okay, platforms in the sea area, like even in the maybe oil and gas. So that's what they use to prepare platforms that they say set up their equipments. People they live there and all that. So it is a very special type of foundation. That's what we call it floating. It's floating in the sense that the underlying soil or underlying substance is soft. That if we are to say, can we place the thing on top of it, it cannot carry. So we design in such a way that it will be able to float despite whatever, whether it's water that is on the ground or sloping sand or whatever. We can still be able to maintain it stand. So that's deep foundation. Maybe we look at deep foundation and the floating foundation in the much later part of this topic. Okay, now for shallow foundation, which is our main topic for today, please go to the next slide. There are three major considerations of shallow foundation, which are as follows. Number one, the depth. Shallow foundations as the name suggests, are placed near the surface and typically have a depth that is less than the width or diameter of the foundation itself. The depth is always lesser than the width or the dimension of the foundation. Okay, so they are used when the upper layer of the soil is sufficiently strong and stable to support the load. So what that means is that when you that's why, like I said earlier, we do soil investigation to check the strength of the soil, the characteristics of the soil. In order for us to decide, okay, we want to use shallow foundation, we should be able to make sure that the soil can be able to carry the foundation so that there will be no settlement on the soil or external factors, erosion and all cannot affect the soil in a much later time. Okay, so what we have now, been able to convince ourselves on that regard, then we can go ahead and then build it as a shallow foundation. Okay, number two consideration when doing a shallow foundation is the suitability of the soil, which I have already mentioned. So the soil must be ideal for the site with stable and strong soil near the surface, such that the load can be able to spread, the foundation can be able to transmit and spread the load to the underlying soil. And the third consideration in shallow foundation is the construction methodology. So that's when you're talking about this, we are also including the economics. In building, three things matters the most. Number one, stability of the building. Number two, the economy. That's how costly or less expensive it is. And then number three is the aesthetics. So that is according to that order. So the most important factor is the stability. After the stability, we have been convinced of the stability. We now begin to look at the cost. So if based on that stability, criteria we have chosen, we now begin to look at the cost to try to manage costs, reduce costs. Then after we are finished with the cost, aesthetics is a secondary need for the building. Okay, so that's the construction we are talking about. So if shallow foundations are easier and less expensive to construct compared to deep foundations, since they require less excavation and all that. Okay, so please next slide. We are now going to the types of shallow foundation. Now, broadly, we are going to look at three types of shallow foundation in this course before we round up. Okay, and the first one is what we call the spread footing or pad footing. Spread footing or pad footing. And then the second one is what we call the strip footing. And then the third one is what we call the mat footing or raft foundation. So those are the three major types of foundation or shallow foundation that we have. Okay, but then each of them say have subtypes. As we go, we will see them. Number one, strip or stripe foundation, also known as also known as continuous footing or strip footing. Is a type of foundation commonly used in the construction to support the weight of a building or structure. It is a long continuous concrete footing that runs along the length of load-bearing walls or other structural elements. So how steel foundation works, it runs along, it's a straight, it's a continuous something. So if we are putting a shallow foundation in this building, for example, first thing that must show you that is a steel foundation is that the edges, the four edges of external edges of this building must have continuous concrete wall. The reinforcement wall will come before the concrete wall, of course. So that's what will show you that it is a strip footing or not. Okay. So and then other demarcations that like the rooms and all that will also carry such, depending on the exact type of strip foundation, because there are different types as we're going to see very shortly. Okay, now what are the key features? Please, next page. What are the key features of strip foundation? Number one is a continuous footing unlike isolated footings, which are individual footings supporting individual columns, or a strip foundation is a continuous concrete strip that runs along the length of the wall or load-bearing structure it supports. Like I have said, it runs throughout. It's not supporting a strip, it's more of okay. Now, the function of foundation is the width of the foundation is bigger than the width of the foundation. That width of this is to be a foundation. You will discover somewhere here where the foundation and where the flip you see that there is a protruding. The concrete width is larger than the width normal wall. So if you are using, for example, 9 inches, or that we call it 225 block wall, the footing might be 100 run across. Then the primary purpose of a strip foundation is to distribute the load evenly over the entire underlying soil. So by doing so, it prevents excessive settlement and minimizes the risk of differential settlement, where different parts of the building settle at different rates. So it will try to minimize differential settlement. The foundation will make the house more stable and distribute the load evenly. Then the next page. Then we look at the reinforcement. Depending on the design and structural requirements, strip foundation may incorporate steel reinforcement bars called rivers to enhance their strength and resistance to bending and tensile forces. So you may have to incorporate what's it called? Reinforcements. Yeah, you may have to be. Not all, not all. Now, if it is a bungalow, for example, and we are maybe trying to do that in a place that is prone to around area that is prone to erosion. So when we use slip footing, so what will determine whether we are going to reinforce or not. Many factors to check are, for example, if the concrete thickness and height of the strips is good enough to support the compressive forces and all that. And then if there will not be settlement that will soon happen, because if settlement happen, we will need tensile stress to avert that settlement. So if there is not going to be any atom of settlement, we may not need reinforcement. But if we perceive that there might likely be settlement due to one or two things in the future, we must use this thing to take care of that tensile stress that we do as a matter of the next picture is the construction. The construction process involves excavating a trench to the required depth and width, placing formwork if necessary, then adding a layer of hardcore or gravel or for a stable base, and then pouring concrete to create a continuous strip footing. Now, there are different types of strip foundation, and they include as follows: traditional strip footings or foundation, stepped footings for sloped areas. I will explain that shortly. Then the next one is raft strip footing, which are used when the soil has poor bearing capacity or when the loads are particularly heavy. Please go to the next page. I will use the drawing to try to explain each of them. Okay, so we mentioned three types now. So the first one we said is normal strip footing. You can see when the line, this is the first drawing you see there is formwork that they are trying to make for the strip footing. And if you can be able to look closely inside there, you see that soil that is there, that you are seeing there, is actually I should say a very bad soil, a waterlogged area. So that's why they have to try to make it to be so. Okay, then the second type is the stepped. Now you discover that some of topography may not be level, evenly level at the same time. So it might be a sloping terrain, kind of, something like that. So when we are doing strip footing for that, we need to make it in such a way that it will be stepped. The step will help it so that it will take care of every sloping effect. And so that's what we call stepped strip footing. I think okay. I did not capture anyone that has. Okay, I think one of them is small and yeah, but I did not really capture it. But that's what it's all about. Then the next one we call math. We call it a raft strip footing. Okay, so that one. So after in raft foundation is separate from raft strip footing. Let me tell you the difference. Raft strip footing. After we have done that columns now, so we will still need to cast everything to cover the whole entire building, make it thick as though with everything. So unlike the mat foundation, which is raft foundation or mat footing, is separate. That one, before we start, we need to even excavate first and remove the baseboards and reach the step of ground first. This one we do not do that. So it's a strip footing. That's why we call it strip raft foundation. Okay, so I think you can go to the next slide. I try to explain some of those types of street footing. Yeah. So there is wide street footing in case where the soil has a low bearing capacity. A wider strip may be used to spread the load over a larger area. So the more volatile the foundation is, it will also determine the larger the street footing should be. There's also pad and street footing as an example. So you have to combine it. Now, a combination of the individual pad foundation and short strips is used. So you go maybe between this junction and the other junction, it will be street footing. But when you get to the junction, you will still put the pad. Yeah. Are you getting it now? So you combine street footing. And then there is also the inverted T-beam. Now, the inverted T-beam, okay, let me explain it. So, normally street footing, normally foundation should be up. T-beam is upside down. So instead of doing it after this thing you cover it, you turn it upside down. You first of all cover flat concrete all along the whole entire stretch first before you now cast the slip. So that's the inverted slip as the name implies. Now, please next stage. What are the advantages of strip footing? Many of them is cost effective, you distribute the load evenly, suitable for various soil types. The construction is very simple, and then it has low maintenance after construction. And then please next slide. Okay, so what are the disadvantages? Number one, it has a limited load bearing capacity. There are some loads that you cannot put on street footing. It will sink the thing, it will just collapse the thing. So it has a very low, can be used. The type of structure is limited to smaller loads. Number two, it's vulnerable to differential settlement. Yes, it is. Because when you have used strips now, remember that when if you not, especially when you did not capture it well and use its sloping place, and you did not use the step well and arrange it such a way that the steps should be able to take care of every, you discover that cracks will start developing, and from that crack, some differential settlement will start happening. Number three, it is difficult to prepare site preparation and leveling for safety. It's more difficult because you need to come to site, look at it, you draw, use what's it called, surveying instrument or whatever, check the levels, know where to place what you want to do, and then so it may take a longer. Okay, so number four, environmental impacts. The excavation required for safety may produce a significant amount of soil waste. The reason is because the safety most like time areas where the soil is already bad. So that one is, so you must have to take the cognizance of the bad soil that will produce, how to evacuate them and where to evacuate them and all that and all that. Okay, then unsuitable for weak or expansive soil. It's not good for so much weak soil. If not, like I said, just the same way that if you put too much load on it, it will sink. If it is also the very bad, this thing, it will also collapse. So when you put. Okay, then please next slide. we are now going to the second type of shallow foundation, and that is called the pad or spread foundation. Pad or spread foundation. Now, um, please pause, excuse me. So, individual columns. Um, they are used for point loads, where street footings are used mostly for distributed loads. So this one is used for point loads. That's why it supports individual columns. Okay, so the primary purpose of a part foundation is to distribute the load from the superstructure, that's the load, every other part of the building, to the underlying soil in a way that prevents excessive settlement or structural failure. Please, next page. There are some features of part foundation. Number one is the design and the construction. They must be constructed with reinforced concrete. Every part foundation they are constructed with reinforced concrete. The size, shape, and depth of the part depends on the load to be supported. So the bigger the load, the more the load, the size, the bigger the size of the part foundation. Okay. Now, but before you do part foundation, there must also be soil investigation so that we can be able to determine the properties, the characteristics of the soil, and the bearing capacity. And then number three, load distribution. The weight of the structure is transferred through the pad foundation to the soil. First, the columns receive all the loads in the pad foundation and then transfer it to the pads. And then the pads now collect it and distribute to the underlying soil. Okay, then the next thing is reinforcement. To enhance the strength and durability of the pad foundation, steel reinforcement bars are often used within the concrete. The reinforcement helps to resist binding and shearing forces that may occur due to structural load or soil movement. Then proper construction. Accurate construction and proper curing of the concrete are essential for the foundations of long-term stability and performance. So we need to cure the concrete, make sure we follow the normal mixtures and all that. Please, next page quickly. Yeah, these are some of the examples of pad foundation, and there are different types of pad foundation, which we are going to see. Types of pad foundation. Next page. Let me quickly name them fast because of the time. Number one is isolated pad foundation. That's stand alone. When you be standing alone to carry his own load, that's how it goes everywhere. So it's called isolated. The next one is square pad footing. Now it can be any shape. You can decide to use square. You can decide to use rectangle. That's the next type. We can also decide to use circular pad foundation. All of them, depending on the function. Of course, the architects will be able to tell us the one that's used. Most times, for aesthetics purposes in the front of the house, like which is you see circular, yeah, a circular column. So if it is going to support the circular column, we should be able to do a circular pad foundation. Yeah, okay, that is just one. So the next one is strap footing, which consists of two or more parts that are connected by a structural strap beam. If you go behind one step, you will see example of the strap foundation. Just go behind one step. See it there. Two parts connected by a strip, so you can be able to carry. That's to make it stronger. Then the last one is combined footing. The combined footing is used to support two or more columns that are closely together. So if the columns are together, we now make it. It's different from the strap footing a little. The strap footing is supporting one column, but the parts are joined together to support one big column that is bigger than one of the strap. So, but in combined footing, you are using combined footing used to support two or more columns. When there are two or more columns, that's when you use combined footing. What are the advantages? Next page. So it's cost effective, simple design and construction, it's versatile, it can be used for various types of structures, including residential buildings, small commercial buildings, etc. Then number four, individual load distribution. Flat foundation support individual columns and or posts, allowing for the distribution of the load from each column separately. Unlike steel foundation, the thing is collective, right? Okay, so then it minimize. There's a minimal excavation because a shallow foundation time, and then there's use of maintenance also. What are the disadvantages? Next page. Limited load bearing capacity, just like the steel foundation, because they are all types of shallow foundations. Their load bearing capacity is highly limited because there are some load that you cannot place on them. They just cave, they just collapse. So there is also risk of settlement due to their shallow nature. Okay, so they are not suitable for poor soil condition. Or when it's not good, don't even think about soil foundation. You can be thinking of street foundation or any other one. Then footprint restriction. The size of the pad foundation is limited by the bearing capacity of the soil, which could pose challenge for larger structures with heavy loads. Then number next disadvantage is lack of uniformity. It's not always uniform in the sense that you can put, for example, let's say 200, 225 by 225 column here. Another place you are putting 300 by 225. Another place 300 by 300. So that is so the columns, if the columns are not uniform, the part foundation will not also be uniform. Then lack of environmental factors. In areas with high water table or flood prone regions, part foundation may be at risk of being affected by water related issues. Right? Okay, so the next page is raft or mat foundation. That's the first type. That's where we're going to stop for today. We'll treat it. Okay, so what is a raft foundation? Now, a raft foundation, raft foundations are large concrete slabs that cover the entire footprint of a building. Raft foundations spread the load over a wider area and are suitable for buildings with uniform conditions or poor load bearing capacity. Uniform conditions because it will cover the entire area. Now, what are the features? Number one, design and functionality. A raft foundation is continuous slab that covers the entire area underneath the building, everywhere. Now, it's always used where we have very bad topography, bad soil type, like where there have been dustbin before. Those where there is a swamp, what how do they call it? Swampy area. You cannot do anything, or muddy ground, muddy type of soil that can press in. You cannot do anything with that part foundation. You cannot say let you do part and maybe you can use strip if it is a little step. But if you have gone to some extent, I know that you must only use. How do you do it? You must remove everything first. Go deep a little. And then after removing, then you now set up your reinforcement and all that, and you're able to cast the whole entire distance. And then you are sure that you have reclaimed that portion of land you want to build. So the load distribution, the primary purpose of raft foundation is to evenly distribute the load from structure to underlying soil, reducing the risk of settlement. And then the depth and thickness. The depth and thickness of the raft foundation depends on the load bearing capacity of the soil, the weight of the building, and other design consideration. The soil bearing capacity of the soil, and then the weight of the building. Also, you take consideration of long-term effects like land movement or the wind effect and all that. Okay, then the next one is the reinforcement. So in raft or mat foundation, steel reinforcement is often incorporated into the concrete too, because you are casting everywhere. So in case there is a movement from up or that want to, the tensile force will subside any type of. So tensile and compressive force, and concrete gives more of compressive, while reinforcement of steel gives more of tensile. But combining the two gives us a perfect blend. Next page. You can see a picture of different types of raft foundation. So you first of all cast the entire this thing. Then before you now start putting columns or whatever you need for each of these things. So let's go to the next page. What are the different types of raft foundation? You have the conventional raft foundation. It's a solid monolithic slab that covers the entire building, just normal, covers everywhere. Then the second one is slab on grade foundation. A variant is this is a variant where the raft is a flat slab directly resting on the ground without deep, excavation. See what you mean? If the ground is stable a little, you don't need to excavate deep again. You just try to put the this thing on the underlying soil. You just remove topsoil, then put it there like that. So that means the ground is a little bit have a little bit capacity to carry. But take note also, even if you want to, of course, the time you use their mind on the time you want to build. Not time you want to build three-story building, you will build. There is no way. So maybe just bungalow that you build and you are sure that the thing can carry, then you can go ahead. Then solid raft foundation. This is the simplest form of raft foundation where the entire foundation area is single thick concrete slab. It is suitable for relatively small and uniformly loaded structures. And then we already talk about the slab upgrade. The next one is slab with beams. Slab with beams. Now that one looks more like a street foundation, but in the reverse order. So after the slab, you still introduce some beams to run across. Okay. Then cellular raft foundation is a variant of slab foundation with beams. This type includes a grade of smaller individual footings or cells within the raft. So there is beam that one incorporates the foundation, there's beam and also there are columns along. Both columns, beams, and that's why I call it cellular raft foundation. Then floating raft foundation. This is done in areas with expansive soil or where soil settlement is concerned. So we try to make it such that it will look like a floating foundation, but not exactly floating, but call it floating raft. It's a raft foundation. It's a type of raft foundation, such that no matter whatever happens in the place, it's not settled. So that's what we call a floating raft. The next one is pile raft foundation. So this type combines pipe with a raft foundation to transfer heavy loads to deeper. So they don't need to excavate too much. They just drive in some pipes to just not too deep pipes to some certain degree, and then the raft will now rest on the pipe. So those are the types. Now, as we round up, let's quickly look at the advantages and disadvantages of a raft foundation. Number one, provides stability and prevents differential settlements. Is suitable for weak or variable soil conditions. No matter how bad the soil is, as long as we are not going building skyscraper or too heavy load, raft foundation can serve. It can it can serve better than both street and pad foundation. So, and of course, it's more expensive when we go to. That's one of the disadvantages. Far more expensive because of the amount of concrete and reinforcement and so forth. Okay, then it reduces the risk of structural damage due to ground movement. Then it is cost effective for larger and heavy structures. Yes, they are comparing it with structures that should have deep foundation. Deep foundation are very, very expensive, generally speaking. But comparing with raft foundation is better, cheaper than it. So it's because some buildings, when you evaluate it, you should be able to check both between deep foundation and shallow raft foundation, which one should be. I told you stability. Can raft foundation carry it? Yes. Now, if raft foundation can carry it, what is the cost of raft foundation and what is the cost of deep foundation? So when you now compare, you see that raft foundation will be quite cheaper, so you can manage raft foundation there properly. Stability, economy, guarantee. So that's what he's looking at here. Okay, so and then the disadvantages. It requires a larger surface area, of course, which may not be practical for smaller sites. So number two, excavation and construction costs can be higher for very large buildings. Number three, In certain soil conditions, it may not be suitable for foundation types. Next page. Thank you for listening to me, and I call for patience quickly and observations also playing. Like we said, when we are designing, we are considering the capacity, bearing capacity of the soil. Number one. Number two, the type, character